Hello there, this video is about percent composition. So I want to relate it first to something that I really love, which is pie. If I wanted to find the percentage of this pie that's cherry, what would you do? First you'd probably look at the mass and be like, okay, so this cherry pie has 6 grams of cherries and only 3 grams of pie crust. I know you might be thinking that's a lot of cherries. I like my pie filled with cherries. So then if you wanted to find the percent of the whole thing that is actually cherries, you would take the total mass would be 9 grams, and the part that's cherry, that's 6 grams. So 6 divided by 9 equals 66%, or 2/3. So right there you were looking at the part over the whole, and that allowed you to find what percentage of the pie by mass is actually cherries. 66%, a strong majority of it. Well, when we go into chemistry and find the percent composition, that's basically what we're doing. Let's look at H2O. So if I wanted to know, okay, in that mass, what percentage of that mass is actually from hydrogen atoms, and what percentage of the mass is actually from oxygen atoms? There we're going to use that same theory as the pie theory. We're going to look at the percentage, which is going to be based on the part divided by the whole. So first, let's figure out the whole. So if you've got H2O, and you had 1 mole of H2O, you would have what mass? That's when you got to go to the periodic table. In the periodic table, we're going to be adding the hydrogens plus the oxygens, that's a plus sign, in order to get the whole of it. So H2O, there are 2 hydrogens and 1 oxygen in it. 2 times my hydrogens according to the periodic table. If you look on the periodic table by hydrogen, hydrogen is number 1. At his mass is 1.0079. If you found oxygen on the periodic table, you would find out when you look at his mass, he happens to be the atomic number of 8, but his atomic mass is 15.999. And when you do 2 times the hydrogen plus the oxygen, you get 18.0148 grams. That's the whole part. That's like the cherries plus the pie crust. So if I want to find what percentage of the pie, or in this case H, or water, is H, I'm going to look at the whole is on the bottom, 18.0148. That's the total mass of water. And the part is going to be the part that's just hydrogen. There happens to be 2 hydrogens. So 2 times the 1.0079. This is 2 times the hydrogens, 2 hydrogens. So now I have the part divided by the whole, and when I take that, I get 0.1119 and some other decimal places. But I want to put this in a percentage form. So percentage is when you're always going to multiply it by 100 to take a decimal and put it in a percentage form. Or in other words, move the decimal places over 2 places to get 11.19% hydrogen. Well, now I've got to figure out what percentage of my water is actually oxygen. What percent is oxygen? Once again, I'm going to do part over the whole. I already calculated the whole. The molar mass of water is 18.0148 grams. And now the part is just the part that's oxygen. There's only 1 oxygen, and oxygen on the periodic table is worth 15.999. So if I take these 2 and divide them, I get 0.8881. I'm going to times it by 100 because I want to put a percentage form, and I get 88.81% is oxygen. So right there I know that of a mass of water, if you had a mass of water, 88% of that mass would come from the oxygen atom, and 11% of the mass would come from the 2 hydrogen atoms. That right there is percent composition of water. Alright, I'm going to do a little trickier one and see how we do. This time we're going to look at Ca3PO4, calcium phosphate. And so I'm going to look at calcium phosphate and find its percent composition. If you think you know what you're going to do, why don't you go and solve it, and then come and look at the end of the video and see if you get the same answer as me. If you're a little lost, I'm going to do it here for you. So let's take it one part at a time. So whenever we're going to find the percentage of anything, we're going to look at the part over the whole. So I think my first thing that I'm going to do is find the whole part. And that's what I'm going to do right here. I'm going to find the whole part. In other words, what's the molar mass of calcium phosphate, this whole compound? And that's when you look at the periodic table numbers. On the periodic table, I'm going to have to look up 3 calciums. There's 3 calciums. And I'm going to have to add to that my P's, phosphorus. There are actually 2 phosphorus, 2 P's. And then I'm going to add to that my oxygens. And there happens to be 2 times the 4 oxygens. This is PO with a little 4. 4 times 2 is 8. there are 8 oxygens. So, start with calcium. I'll look up calcium on the periodic table. If you look him up, he's 40.078. That's how many grams he is per calcium. And I'm going to multiply that by 3, because there happens to be 3 calciums. Looking up phosphorus, if I look for him on the periodic table, I'll find P. P will have a mass of 30.974. And there happens to be 2 of them, so I have to multiply this by 2. And lastly, I got to find oxygen on the periodic table. If you find him on the periodic table, he'll be at 15.999, and there are 8 of them, so I have to multiply this by 8. Oop, that got a little funny, sorry. So if I punch all of this into my calculator, it gives me a 310.174 grams. That is the molar mass of calcium phosphate, the Ca3PO4-2. That's the whole mass of 1 mole of calcium phosphate. Okay, now that I've got the whole part, when I find percentage, I'll have the bottom line fraction for all of them. So I'm going to start by finding the percent that's calcium. Looking at the percent that's calcium, it's part over the whole. I know the whole is 310.174. And the part is going to be the part that's calcium, in this case 3 calciums. So I'm going to do 3 times what calcium is worth, 40.078. If I do that in my calculator, I get 0.3876. I'm going to multiply by 100 to get in percentage form, and I get 38.76% calcium. One part done. Moving to the next part. I got to find the percent that's P, and yes, you got to look at each atom. So now I'm looking at percent that's P, or phosphorus. Part over the whole. I've got the whole part already, 310.174. Now I got to find the part, 2 phosphoruses, so 2 times 30.974. That's the part I already looked up in the periodic table. If I divide those two, I get 0.1997, which, after multiplying by 100 to get into percentage form, gives me 19.97% P. And lastly, I've got to look at my oxygen. What percentage of the molecule or compound is oxygen? Part divided by the whole, I've got the whole being 310.174. The part are 8 oxygens. So 8 times the mass of oxygen, that's my periodic table number, 15.999. If I divide those two, in other words I do 8 times the 15.999, divided by that 310.174, I get 0.4126. Multiply by 100 to get my percentage, and I get 41.26% oxygen. So if the question said, what is the percent composition of Ca3PO4-2? It would be everything that's in this blue box right here. That is a percent composition of calcium phosphate, which means any mass of calcium phosphate you have, 38% of that mass is calcium, 19% of that mass is phosphorus, and 41% is oxygen. To double check, you can always take all these numbers and add them up. If I take the 38.76 plus the 19.74, 974, and 41.26, I actually get 99.99. You should get 100, but if you think about it, everything we did was rounding, because this decimal places goes actually farther than that. And by that rounding, I actually kind of lost a little bit of a value. So it should add up to 100%. Sometimes it doesn't get exactly 100% because we did have to round at some point. But that's always a great double check. If you don't get something very, very, very close to 100%, you might have done something wrong. Alright, I hope that helps. Put some questions if you have any.